do this quite quickly. So to those of you who are watching on YouTube, 22 plus reasons, because I found a lot more as I was going through this, why you're going to love the 535 in your calculator. So here's a long list. I'm not going to go through them now because we are going to go through them in the presentation, but this is sort of the direction that we're going to take. I'm hoping that will be done in under an hour. But yeah, pop the questions into your chat and let me know. So the first things first that we, and here's reason 23, see what I mean, the home button. So home takes you from whatever other mode you're in back to normal mode. So if you're lost and you're sick of pressing mode and 0 for normal, then you can press the home button and it takes you back as well. And then of course our 4 different modes, which I will go through in a minute or two. So reason 24, on top of the other 22 reasons that I'm going to tell you about now, is that your simulator is free. So this link here is free. If you click on it, it will directly download the simulator to your computer, and you can use it exactly like the one that I'm going to use now in this presentation for you. So the first thing that I want to show you is the class mark shortcut, because as a teacher, this is something that we really need to know. So it's very easy. We're going to use our fraction button and make sure obviously that you're normal, so you can just press home for normal mode if you're not there. We're going to press our fraction button. Then at the top, we type in whatever we want to convert our class marks to. So if we set a test which was out of 70, and then we want to convert all of those test marks into a percentage out of 100, if we were making it smaller for a CAS marks, something out of 20 or 25 or 30, then that would go at the top. So we're going to type in 100 over here. Then at the bottom of your fraction, you're going to type in the total that your original test is at. So in our case, it was out of 70. Then you press your right arrow key just to get out of the fraction, and we multiply by your first student's mark. So if your first student got 40 out of 70, then we type in 40, we press equals, and we get 57 and 1/7. And if I change that, you'll see it gives me a decimal, so 57,14%. That's the hard part. For the rest of your class marks, all you have to do is type in the next student's mark. So leave that on your screen, and the next student gets 55 out of 70. So we type in 55 and we press equals, and he gets 78,57 or 79%. And your next student gets 23. So you just type in 23 and equals, and they get 33% rounded off, and so on and so forth. So you can do your entire class list like this. It's really easy. It's very quick. And that is especially just for maths. Well, actually for any teacher. And you can do it on any Sharp calculator. It has this constant function as well. Now, the next thing that we absolutely love, and this is for grade 7, 8, and 9, more so than the FET phase does, but bear with me because there's a mix of everything, is our drill mode. So to access drill, we press mode and we choose 3 for drill. Then we're going to choose 0 for math. You can also use table, and what table does is it just allows you to practice your times tables. So it works the same way as this one. So you can choose 25, 50, or 100 questions using your up and down arrow keys. Then you can choose your left and right, will allow you to choose the type of questions that you're going to do. Okay, so once you've selected that, you press equals, and then it's going to ask you a random maths question. So we just have to type in the answer on the calculator. So 10 minus 7, we're going to type in 3, and then we'll press equals, and we'll get a tick and a new question. Now, if we get the question wrong, the calculator is going to mark it wrong, obviously, and then ask you the same question again. And it's very patient. It's going to keep asking you until you get the answer right. Now, I'm very heart-sore to be answering this question exactly. But if you get stuck and you don't know the answer, you can always ask the calculator for help. So you can just leave that space blank and press equals, and it will show you what the answer should be. You'll see that you don't get a mark for it. So obviously students can't cheat by just asking what the answer should be, because what they'll get at the end is 0 out of 25. But it is a great way to practice mental maths, particularly in the younger grades before you start teaching things like finding the lowest common multiple, teaching fractions, teaching factorizing. All of that requires a very good knowledge of your multiplication and addition and subtraction and division. So this is a great way to practice that and to get the juices flowing before they get there. So I'm just going to cheat through this a little bit. So you'll see at the end, I won't get any marks for this. Just do one last one. Then I'm going to press enter, and then I will say equals, and I got 5 out of 25, or 20%. So you can see I didn't get any marks for cheating. So what's really nice about this is that you don't have to do any marking yourself. All you have to do is look at the results. And what's really nice as well is the calculator generates random maths questions. So your set of questions are never going to be the same. Your students can't cheat off each other either. You can have races in class because it's fun. So there's lots of nice things to do with the mental maths questions. And then again, for the table mode as well, you can see you can do it in either serial, which is in order, or counting in, and then you can also do it randomly, where you mix up your timetables as well. So let's move on to data handling and basic statistics. And again, I'm going to demo this on the calculator. The reason I show the steps in the PowerPoint is because I'm going to share the PowerPoint with you afterwards. So it's a nice thing to have available to you. Sorry, I just want to make sure I can see all my data here. Right, so let's go to our statistics mode. So we're going to press mode and 1 for stats, and then we're going to choose 0 for single data. Now there's a whole bunch of other data things that we can use, but in high school, the only two that we're required to know is our single data and our linear regression, which is 1, and I'll cover that afterwards. So let's do single data. So all we have to do is type in our marks. So let me actually just share this screen so you can see exactly what I'm typing in here. So I'm going to start with 34 and equals, 44 equals, 99 equals, 39 equals, 10 equals, 56 equals, 71 equals, 71 equals. You could also go up and change the frequency here to 2 if that was something that you wanted. 41 equals, 93 equals, 89 equals, 11 equals, 77 equals, and 68 equals. Althea, just to answer your question, a register is automatically generated. So when you logged in with Zoom, it logs you in with me as well, so that I know exactly who's attended. So you're all sorted. I know you are here, so don't panic. Okay, so once that's done, you can go back up and just check through. Oopsie, I have now filled in the wrong side. Oh dear, that should be a 1. You know what, I'm just gonna start again. Sorry guys. So let me just clear that all, and there we go. Oh, I did something very, very silly. I wasn't paying attention. Whoops. Okay, so let me just make sure that it's in the right there we go thing here. 56, 71. I got distracted when I was mentioning the frequency. 41, 93, 89. If only there was a copy and paste function on a calculator. Hey, it would make things probably a little bit dangerous, but also maybe a little bit fun to do. Okay, awesome. Yes, so Jeff, SD is for single data. Everyone confuses that. They've never changed it, even though we've asked them to. I don't know what else we would call it. Univariate data. I suppose they picked a simpler English than univariate. But yeah, I understand your confusion. So once you've entered all your data and you've checked that you're happy that you've got everything and everything is correct, if you wanted to go back and change something, so for example, that 10 should have actually been 50. All you would do is highlight the number that you want to change, type over it, and press equals, and that will input the data in for you and just write over it, basically. Once you're happy with all of your data, you can just press the change button, right? So change, if you press change again, it will just take you back to your table. So you can go and add data or change anything you like as well. It makes for fun, interesting discussions when you start saying, okay, what happens to the mean if I add an extra data point? Or what happens to the standard deviation, and so on. So speaking of those things, we'd like to be able to find them really easily, and that's what we're going to do. So we're going to press alpha and 8 for, you can see in green it says stat, so alpha and the green button for stat, and then we just press 0 for statistics, and then you can see your summary. So your number of observations, your average is 60 cups of coffee per day. Your standard deviation, we don't use SX, we use sigma X because of the formula. So you use your population version. So that's 24. Your sum of X, your minimum, quartiles, median, and your maximum value. So your 5-number summary is all there for you as well. Cool. So that's basically basic stats. If you wanted the values individually, which has actually come up, and so let me just show you that quickly as well. You can have access to those individual values. So to get to those, you would just say alpha 8 and then choose 2 for variable. And then you can see you've got all of those as well. And if we said alpha 8 and 3 would give you the sums or the sum squared, and then of course your 5-number summary is at number 4. So you can just choose any of those values as well. So from there, let's jump into the linear regression. I wonder if this is the best place. Okay, so we're going to just type in. So from here, we're going to press mode and then 1 for stat, and there you can see the linear regression formula. Maybe, Jeff, it's because it doesn't have a formula, you know, as a where the rest do. Maybe that's why they chose SD. I know it was on the old Sharps as well. Maybe it's a nod to history. Okay, so we've got 2 and 17 as our first coordinate. I won't tell you the story behind this because when I actually put it in, it's actually a terrible example. I was talking about number of years driving experience and number of accidents. I hope no one driving after 2 years has 17 accidents in a year. just say. Okay, so with regards to linear regression, you can either type in all of your x's first and then go back up your table and type in all of your y's. Or what you can do is type them in together. And that's how I like to do them, because linear regression is about a relationship. And also, you just saw the silly mistake that I made earlier with, sorry, let me actually do this so you can see why I'm shifting up and down. So you saw the mistake I made earlier just by going back and editing something. So it's a good idea to write them together in a coordinate pair. So the first value or coordinate is 2 and 17, right? So we're going to type in a 2, press our X, Y button, type in 17, and then press equals. And you'll see that the calculator will automatically put it into the table for you. So the next one is 4, your X, Y button, and 15, and equals. Then it's 6 and 12, and equals. Then we've got 8 and 7 equals, then 10 and 10 equals, and 12 and 4 equals, then we've got 14 and 5 equals, then we've got 16 and 3 equals, 18 and 1, and 20 and 1. Okay, so let me just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. All right, so everything's here. For distraction purposes, I'm just going to go back here. All right, so once you're done with that, you can again press the change button. Okay, and now we want to look particularly with regards to linear regression, we want to be able to find the regression line. So that you can see this was lined out in the normal standard single data. So this, we just press 1 here, and you can see your A is your y-intercept, so that's 17.47. Your B, or your gradient, is negative 0.91. And then, of course, your correlation, you can see, has a strong negative relationship. So, in fact, I did actually draw the graph for you to see, and you can see quite clearly it's got a strong linear negative relationship, which is quite cool. So here are all the steps for you. And that magical XY button, which we'll come back to in a little bit. And then, of course, your regression equation, which is over there as well. So it's really nice. I mean, the linear regression alone is quite something. I mean, it makes statistics so easy. Well, I mean, it makes part of statistics so easy. The analyzing it part is the student. So reason 25 is because on your table mode, your asymptotes actually look like asymptotes. So I'm going to show you a very basic example quickly in your table mode. We will come back to table mode towards the end because there's a lot of nice things that you can apply in teaching with table mode, which is really cool. So to get to table mode, we press mode and 2 for table. And I'm just going to show you how to find factor pairs of a number. So for example, if we wanted the factor pairs of 36, it's my favorite example. You press the fraction button. Next to the fraction button, you have a green button called RCL. Now, if you press that twice, it will make an X. You can also use alpha RCL, up to you. I'm lazy, so I like the quick way, which is why I use RCL twice. So once you're happy with that factor pairs, you can then press equals, and it will ask you for a function 2. We're just going to ignore function 2 for now. It's not important. I'm going to leave my start at 0. And because we're looking for factor pairs, obviously my step should remain at 1 so that I can see every single thing that divides into X. Now, here's that beautiful asymptote that I was talking about. So it actually looks like a striped line. So when a student sees a striped line on their graph, they know that they need to draw a striped line on their actual graph as well. Then, of course, here are all of the factor pairs: 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 and 7.2. So no, 5 is not a factor because it has a remainder. Then we can go down, we've got 6 and 6. And if we go down some more, we can see that it's now switched sides. So we know we have all the factor pairs. What's also really, really nice about it, and I didn't actually include it as another awesome reason, is even though we started at 0, it doesn't matter because you can go up your table or down your table for as long as you like, and you're not going to run out of space ever, which makes teaching stuff a lot of fun. And I'll show you some examples of this. Just now, when we look at simple and compound interest, we look at annuities, I'll show you a really nice way for teaching the solving of trigonometric trig equations and that confusing, lovely K. So there's lots of nice ways to use your table mode. So let's go back home. I mean, back to mode by pressing home. And let's talk through some of the new functions that we've had. So the first one is obviously prime factors, which we've seen before. So you type in 87, you press equals, and then you press second function and exp, and it will give you your prime factors of your number. Now, if your number is not a prime factor, I'm hoping this one isn't, and you press second function exp, you'll see that the dot or comma behind it just goes away. So then you know that is a prime number. Now, some other nice things that we've added is the highest common factor and the lowest common multiple. So, and what's really nice is you can add as many numbers to this as you like. So today I was busy creating some grade 8 fraction videos to help teach fractions. So those will go up onto YouTube hopefully soon. But it's using your lowest common multiple to teach fractions. It's actually a really nice way to explain how an LCD or a lowest common denominator works. So let's say, for example, we want the highest common factor of 72 and 48. So we say 72, then we press second function and we press 2, and we'll get GCD, which is greatest common divisor, exactly the same thing as highest common factor. Then we type in 48 and we press equals and we get 24. Now you can add more numbers to this list quite easily, and you can add as many as you like without running out of space. So it's really quite a flexible function, which makes it quite nice. Then, of course, you can do the same thing with your lowest common multiple. So to get to that, we just press second function and 3, and then your number and press equals. And again, you can add as many as you like. So I'll add both at the same time, just so you can see that it's possible. And then you must always obviously end off with a number and press equals. So our lowest common multiple of those numbers is 288. So again, here are all of the steps. I will share this presentation with you in the chat at the end, so that you can have it and go through it. And then, of course, I will upload it as well as a PDF onto Maths at Sharp, and you can just download it from there as well. So there's some awesome time questions and ways to find time that you can do. So of course, I always use minutes as an example, but I want to change it up a little bit. Let's say, for example, you have 300,000 seconds and you want to know how many hours and minutes that is. So you press 0 in the place of hours, and then you press DMS. Then you press 0 in the place of minutes, and you press DMS. And then you type in your seconds, so 300,000 seconds, right? And we press equals, and it gives us 83 hours and 20 minutes. So a really nice, easy function. So the question Solia has just asked is this calculator programmable? The answer is no, it's not. And in fact, it is approved by the Department of Education, and we are partnering with them. We've actually put a lot of these calculators into schools in Gauteng, which is really awesome. So no, so programmable is actually when your calculator, you can actually program it. So you can type in an equation, and then it's expected to be able to ask you the inputs and then solve that equation for you. That would be considered a programmable calculator. In fact, most calculator companies no longer make programmable calculators because they are quite expensive, and the demand for them is very low because these calculators do so much already, so which is really cool. So the next thing with regards to time that I want to show you is finding the amount of time. So let's say, for example, I am traveling from Joburg to Durban, and Durban is 650 kilometers away. Okay, so clearly not Durban, past Durban to the south coast. So I'm traveling 650 kilometers, and I'm doing an average speed of 127 kilometers per hour. Very naughty. Don't tell me that. So what I do is then press equals, and it gives me 5 hours and something. So I'm going to guess around 10 minutes or so. So let's check. So what we do is we just press second function and DMS, and it gives us 5 hours, 7 minutes, and 5 seconds. I didn't plan that, I promise. Thanks, Mbusi. I appreciate that comment. So that's quite a nice function, especially with students who are doing both both science, physical sciences, because the time comes up a lot, but also in grade 9, you're expected to be able to do some time calculations as well. Now, this one particular function is also really nice for Math Lit students. You know, we always get that Susie train station question, or how long does she spend watching TV, or some sort of question like that. And it's such a difficult one because of the number notation that we use for hours and minutes. It's different to our normal decimal notation. So we can actually say, for example, we can actually do a calculation of hours on the calculator. So if Susie gets on the bus at 9:45 and she gets off at 12:25, how long was she on the bus for? Okay, so we're going to say 12 and then 25, so later time first, minus 9 DMS 45 for 9:45, and we say equals, and it gives us 2 hours and 40 minutes. Now, the great thing is you can also, like we did where we had a decimal answer and we changed it into hours, minutes, and seconds, we can change this back into decimal notation as well. So you can get it in both fraction and decimal, or you can take it back to the time or hour notation as well. So it works both ways, which is really handy for those particular questions as well. Cool. Any questions? Are we happy so far? We're motoring along. Fantastic. Okay, so the next thing that I want to show you is an awesome shortcut for Pythagoras. So in grade 8 and 9, when we do Pythagoras, we're just looking for our hypotenuse. But this becomes particularly useful in grade 10, 11, and 12 when we do trigonometry as well. So we're still in normal mode. Let's say, for example, the base of your triangle is 5 units and the height is 12 units, and you want to find out what your hypotenuse is. Now, if we were talking trigonometry, we would have a p coordinate. So in your Cartesian plane, you would have a p coordinate with a 5 and a 12 over here. Pardon my handwriting. So what we do is we type in 5 first, then press our X, Y button, and then say 12, and then we say second function and 8. And that gives us R, which is our hypotenuse theta, and our angle, which is 67,38 degrees. Thanks, Althea. So this is quite a nice, handy function to have as well. What's also really great is if you're working from the hypotenuse and the angle, you can also move it back into your X and Y. So if I typed in 13 and X, Y, and 67, 311, and we say second function and 9, you can see above 9 it says 2xy, then it will give us back our original coordinates as well. So you can use both. The common question which I see is going to pop up, can you get the angle in radians? Yes, absolutely. So all you would need to do is, you see this little degree sign over there, you can just change it by saying second function and DRG, and then we'll just redo it. So if I've got 5, if my X is 5 and my Y is 12, there's my radians and obviously my hypotenuse length, which is still the same. So very easy and quick to change over. What's really nice as well, which I always forget to mention, but I probably should, is these values. This R is stored in your X memory key, and your theta is now stored in your Y memory key. So if you wanted to now do a calculation of theta, so for example, sine of theta, you could just say sine and alpha Y, and then it would give you a ratio as well. So it's a really nice backwards and forwards to be able to use both the X and the Y memories. So obviously, if you do this calculation, it's going to overwrite any previous memories that you had. And if you wanted to check your memories, which I didn't actually mention in my list of cool things, is you can just press alpha and then 9 for memory, and it gives you a list of everything that is stored. So you can see exactly what's saved into memories as well, which is occasionally handy, as I just proved to myself. Okay, so let's talk recurring decimals. Any questions? Are we still good? Still happy? Okay, fantastic. So we're still in normal mode, and let's say, for example, you get, let me just change back to degrees before we get weird answers. So Leah's asked, if you forget that something was stored in memory and try to store something over it, does the other one get deleted? Yes. So if you overwrite memory, it will obviously delete what was underneath. So it's just, you know, if you store it into another letter, it will obviously be in a different memory value bank. But if you had something in X and then you overwrite it, yes, it would be overwritten straight away. Cool. So let's say, for example, we have 45 divided by 7. Okay. And that gives us this beautiful mixed number fraction, and we can change it into our improper fraction and into decimal. We can also set up our calculator with a recurring decimal by just pressing setup and then choosing 5. And we just turn it on by pressing 1. Now, if we press change, you'll see it will give us a recurring decimal and then a normal decimal as well. Thanks, Awil. So that's quite a nice one. I know for grade 8s and 9s when they're doing recurring decimals, and I think technical maths also does something with recurring decimals in grade 10 and math lit guys, if I'm not mistaken. So that's quite a nice one to have as well. Let me show you again. So all you have to do is you only have to set it up once, unless you reset your calculator, and you have to be very purposeful about resetting your calculator. So to reset your calculator, there's a little button on the back, and you have to press it with the tip of a pen in order to reset it. Otherwise, you can say, if I'm not mistaken, second function and setup. No, man, that's obviously not right. Second function and alpha, and then you can press reset as well. But if you don't do that, all you have to do is press setup, and then one or other things that I need to probably mention quickly is your editor, but I think it's later on, so don't panic. So recurring decimal, you can just turn it on by pressing 1. And then decimal points, just as a side note, you can choose whether you want a dot or a comma in your answers. So it's really a preference thing, up to you, but nice to have. I mean, it's just one of those extra, ooh, my car has a comma. Thanks, Sitim Bekile. Sorry, I probably butchered that. Okay, so all you do is turn it on, and then any of your calculations that you use with a recurring decimal will give you a recurring decimal answer. And it's really nice to use because it will always show up and it will round it off correctly as well, which is very handy to have. So from that, here's another reason. You can change your answers. So if you are doing, and this is particularly nice for the math lit guys, if you're doing a lot of calculations with money and you want it in decimal answers, and instead of having to flick through your change before you get a decimal, you can then set it up. Thanks, Palani. You can then set it up so that it is answers automatically in commas, and then if you press change, it will give you a fraction. So to do that, we're going to go back to setup, and we're going to choose 2 for editor. Now, the old prior to this calculator was the 531. I like to call him Grandpa Sharp with love and affection, because you had everything was written on one line. So your fractions had that little R. I'm making little R signs and you can't see me. So yeah, so that's what line is for. Then you have right view. So right view is what we're now used to. Most of us are used to, where you can write your calculation exactly how it's written in the textbook. Now, if you want your answer to be displayed as an exact answer, in other words, as a fraction or a surd or with pi, then you would choose 0. And that's how your calculator comes set up. But if you press 1 for approximate and you now do a calculation with decimals, you will then get an automatic decimal answer, and then you press change and it will take you back to a fraction. But your first answer before anything happens will be this decimal answer here. So it's just a nice thing to know about if you are perhaps doing decimal calculations with your students in grade 8 or 9, or if you are in math lits and you're doing money calculations as well. So how do you fix that, or how do you change it back to the original way? Because we're all used to seeing everything in fractions. You just say setup and then 2 for editor and 0 for right view and 0 for exact. And now if we did it, you can see that it would automatically give us the fraction instead. So it's just an easy way to change that, how the answer is displayed. Cool. Now we have a very awesome random function. Okay, and I love this function. I love teaching probability. I think it's an awesome topic. So if we press second function and 7, you'll get a menu with random, random dice, random coin, and random integer. Okay, so I'm just going to go briefly through them all with you. So random does random numbers between 0 and 1 as 3 decimal places, and you can just press equals and generate those. So it's quite a nice one for practicing fractions. And if you do this, like so, you can practice rounding off fractions to a certain number of decimal places. So the students can generate their own decimal numbers, which is quite fun. Then, of course, we also have your dice, which is exactly like a dice. And so you just have numbers between 1 and 6. Then we have a math coin. So that just does numbers between 0 and 1. Random numbers between 0 and 1. And then the last one is my particular favorite, which allows you to generate between any set of numbers that you specify. So if, for example, you want to say, okay, I have 2 dice and we are summing the dice. So we're going to roll the dice and sum. So my smallest sum is going to be 2 and my biggest sum is going to be 12. Then I can set it up to say between 2 and 12 and press equals. And it will just give me random sums of the dice. Or if I wanted to do the lottery, then I could say between 1 and 52 and then actually play with the lottery with the students. So what I will do is ask them to write down their 6 random lottery numbers between 1 and 52. And then we do a draw on the calculator. So they circle the numbers, they get it correct, and we see who would have actually won money, which, as the case is going, is hardly ever never. Well, what did we expect? I mean, it's like 1 chance in 100 million billion. So it's crazy. Bongani has a question. He says, is the calculator an ordinary scientific calculator, right, which can be used for learners at school? And the answer is yes, absolutely, 100%. It's a normal scientific calculator. You can use it in school with your learners. It is approved by the Department of Education. So 100%. You are absolutely allowed to use it in class. And the best part is it's cheaper than the other one. Just saying. So there's some really nice ideas for playing with your random function. You can create a tally table. So if all the students in your class have the calculator, then like I did, you can generate random numbers. You can throw the dice and count how many 1s, how many 2s, how many 6s, and then create a tally table like that. You can separate them and let them play snap. The coin and dice game is awesome. So what you do is you have all of your students stand up, and then you ask them to choose a number between 1 and 6 and to show you that number using their fingers. So they'll display 5 fingers or 4 fingers, depending on the number that they've chosen. Okay, then you roll the dice. If they pick the same number as the number that you rolled, they can stay standing. If they haven't, they have to sit. Now, usually it takes 2 or 3 rounds max before all of the students are out. And then they're all very disappointed because, you know, they didn't win. So what you do is you play the coin game with them. So then they choose between a 0 or a 1. Okay, and obviously, because the probability of choosing a 0 or a 1 is 50%, whereas the chance of choosing the right number on a dice is 1 out of 6 or 17-ish%. Obviously, the coin game is going to last a lot longer with the students. And so they get very excited about, you know, winning the coin game. So I often give away a calculator when I come and see them. So thanks, Zariah. I appreciate that comment. Let me see, there's another question. Cool, it's a pleasure, Mongani. Okay, so there's lots of nice ways to play games with them, particularly as we introduce probability. Thanks, Malia. Okay, so let's talk percentages quickly. This is particularly nice for your grade 8s and 9s, and then again for your math lit guys. So there is a whole percentage workshop available on Zabuza if you're looking, but I'm just going to show you the basics. So one of the nice things is let's say you have a value which is 120 and you want to find 30% of 120. Then you can say 120 times 30, second function, and 1, and it gives you 36. So 36 is 30% of 120. Okay. Then the next thing that I want to show you is that. Okay, and I'll show you backwards and forwards as well. Okay, so I'm getting lots of comments. Give me a second. Let me just catch up with you. Yes. So Leah says she's been using the calculator for over a year now, but she always comes across something amazing. Oh, yay. Thanks, Leah. Lindiwe says an awesome calculator, but you need a manual. Yes, 100%. So we do actually have a manual that I'm happy to send to you with all of this stuff. And I will, of course, in the chat function at the end, upload this presentation for you to download as well. And then I will make a PDF version as well that you can download off that. But I'll send the link to that on Monday for you. Then Mola Telo, can you record? Yes, in fact, we are recording right now, so this will be on YouTube for you, and you'll hear me answering you. Sadiqa, thank you. I always appreciate it. Yay, you found the manual online. That's fantastic. That's the goal. Maths at Sharp, guys. Oh, I'll tell you about Maths at Sharp at the end of it. So back to that. Boring stuff, I know. So let's say, for example, you have a cost price, which is 205 Rand, and you want to add that. So again, you just say plus 15 and then second function 1, and that will give you 234 Rand and 75 cents, including that. Now, if we wanted to find the price before VAT was added, so I'm going to use the same total, 235 and 75 cents, and then what you do is divide by 115%, and that will give you your original amount before that as well. Thanks, Nombula. I appreciate that. Oh, I'm feeling so loved today, guys. Thank you. So that's that question. What I wanted to show you as well is I was recently going through the syllabus, and with MathLit, you have to be able to do simple interest manually without using a formula, which I don't understand, but hey. So let's say, for example, your initial value is 1,500 Rand. So with simple interest, because you're adding the same amount every time, your best option is just to work out what that amount is. So 7% of 1,500 Rand is 105 Rand. So then what you would do is just create a constant chain with your calculator. So you'd say, after year 1, I would have 1,605. Okay, then you just say plus 105, and that creates your chain, and then you say equals, and then if you keep saying equals, you will see the chain slowly grow. So you must just keep tabs, obviously, on your number of years. Now I'll show you another way using the formula just now on the table mode as well, but that's just a nice way to do simple interest manually. You can also do compound interest manually, which is also really cool. So we'll start again with 1,500 Rand. Then this time you're going to add 7%. But instead of adding, finding that initial value, you just keep adding 7%. Then you say plus 7%, and so on and so on. And that will also give you the same compound interest formula. Also compound interest over a number of years. So this is reason 27 is you can also use this for teaching. Hint for grades 7s, 8s, 9s, even younger grades as well. But I'm assuming we don't have many, except for Stika, you're JP Prep, but I think you do grade 7, right? So those are the two. Then, of course, you also have the user-defined shortcut key. So if you know you're going to be using the percentage key a lot, like you're doing compound interest manually, then what you can do is actually store the percentage function into your shortcut key. Now, don't panic. You can just overwrite that key anytime you want, or just reset your calculator. So it's not stored indefinitely. And you can store whatever you like, as long as it is already on the calculator. So it's normally something that you would press second function and then that function for. And it's just to save you some button presses. Michael, I see you raised a hand. Do you have a question or are you happy? Must I repeat that? Okay, let me just show you again. So if you wanted to, for example, save the random function into your D1 key, okay? So you would say store and D1, and then you would press second function 7, and let's choose the dice. Then whenever we want to use the dice, we just press D1, and then it automatically comes up for us. So it's just a nice short, that's why it's called the shortcut key, because it's for you to choose which shortcuts you actually want to save. So it's very user-friendly as well. Then, of course, we have a dedicated Pi button. And I said yum, and I'm feeling particularly lame as I look at it now. But anyway, so let's find the area of the circle. So you've got a Pi button. Let's say your radius is 3 units. Okay, so there's your pi. So it's pi times r squared. And you'll see when you get the answer, it gives it to you as 9 pi. And then, of course, we can change it to our normal one as well. Then we've got logs. So are there any grade 12 teachers? So we do have logs. Yes. Awesome. Okay, so Leah, let me see a couple of people. Okay, fantastic. So nice to have such a range and of diversity. Thanks, guys. So let me show you quickly how the logs work. So you've got obviously your standard log, which is this button here, which means you have a log base 10. So if I type in 100, it will give me that. Now, if you want a log with a different base, so you have second function and your pi button, then you can type in any base, and then you just shift it over to type in the number and press equals. Michael, yes, the manual is available online. What I'll do is at the end, I will put it into the chat function for you as well. So along with this presentation, I will also share the manual with you so that you've got it. Okay, cool. So we're nearly at the end here. So just a couple more fun things. So give me another 15 minutes, guys. I know days are long and tiring, but we've got this. So before we begin, when you are teaching functions, I actually did pull this off our term 3 work, but I do think it's a nice thing to know. GeoGebra is fantastic for drawing graphs. So if you have access to this, or your learners have access to a computer, this is a really epic, really epic app to be using. If, however, you want to do it manually, worksheetworks.com has got graph paper. So if you're looking for graph paper that you can just print out, because I don't know if they even sell graph paper. You know, you used to get the books with graph paper. I don't know if they do that anymore. But if you're looking for graph paper, then, and you just want to print out couple of pages, then Worksheetworks is really nice. They've got lovely free resources. If you are teaching primary school and maybe even grade 8, they've got a lot of lovely worksheets that are all free as well that you can download from there. So let's talk teaching graphs. So what I did is on the calculator, and I'm not actually going to do it on the calculator here because you've sort of seen what the mode is. I'm just going to go through the steps with you. So in table mode, what you would do is type in an X, leave function 2, and then go and look at your coordinate pairs. And you can see they're all identical. Okay, so if we drew that on a Cartesian plane, it would be a straight line graph with an angle of 45 degrees. Now, what happens if we multiply the X with 2? So in function 1, we leave the X as is. And then in function 2, we put in a 2X. Okay, and we look at the 2 coordinates. And you can see from the tables that I've added to my images here, you can see that answer 2, which is for 2X, has doubled all of the y coordinates for the first graph. So if we drew that, what would it look like? And I'll show you in a sec because I do have the graphs drawn for you. What happens if instead of 2X, we multiply it by minus 2x. What would happen to the slope of the graph then? So if we drew it according to, if we've plotted our coordinates and we connected the dots, what would it look like? So here, the black one is our original y is equal to x graph. Then the red one is our y is equal to 2x graph. And the blue one is our y is equal to negative 2x graph. So we can see when our value in front of x is a positive and it's bigger than 1, it gets steeper. Now, obviously, we could also multiply it by half and we would see that it would get less steep. If we multiplied it with a negative number, we can see that it is reflected about the y-axis. So you can see that here in this blue graph. So there's a lot of nice exercises. I'm obviously just doing this very briefly with you, but there's a lot of nice exercises where you can explore what happens when you change the gradient and what happens when you change the y-intercept, which is what I'm doing in this set of graphs. So here I've done just an x and then I've added in 1. And in the next one, what if I shifted it down? In other words, I changed it to x minus 1. Then we can see our original graph, which is just y is equal to x, is here. And then x plus 1 goes up 1. And you can see that all of it's equidistant from the original graph, a distance of 1 unit. And if I look at the second graph, which was x minus 1, you can see that it is come down as well. So that's a nice way for, and I've done it with just the most basic of graphs, but you can use this for hyperbolas, for exponential graphs, for parabolas, for all of the graphs, and explore different concepts. And in fact, in our grade 10 functions study guide, which I've just redone middle of the year, if you want that, it is on Maths Sharp. Otherwise, email me or send me a message and I'll send it to you direct. So it's just a function study guide chapter that you can use. It's got notes and exercises and stuff. And then we also explore the various graphs using this idea where we look at it and try and discover it intuitively. So what I want to show you here is simple and compound interest on table mode. Okay. So I'm going to go to mode and to the table. And then in my initial my first function, I'm going to just type in a simple interest function. So I'm going to have 5% times x and close my brackets. Okay. And then if I go quickly through, you can just see that it keeps growing by 50 Rand every year. Okay. So now I'm going to leave my simple interest as is. And in function 2, I'm going to put in a compound interest formula using exactly the same values, but obviously as a compound interest instead of as simple interest. So I'm going to use my exponent button and x and equals. Now we can see initially, obviously, it's the same amount that we put in. And after 1 year, it's the same amount. But after 2 years, this compound interest has gained an additional 2.50 to the simple interest. And that means we took 5% of the previous year and not 5% of the original amount. So we can see with simple interest, we are always adding the same amount, but with compound interest, we're adding the percentage of the previous year. So it's really nice. And then what you can do is lots of questions. How long does it take your simple interest to double? So we just scroll through, it takes 20 years. But if we look, how long does it take our compound interest to double? It takes 15 years. And then we can say, when does your compound interest double your simple interest? 2, 8 is 56. So it's around about 35 years. So you can see that's that as well. So it's a really nice way for teaching simple and compound interest on your calculator as well. Cool. Then teaching annuities. Now, I did this, I think in term 1, but I do want to repeat it because it's really cool. And the application for this, because your table is unlimited, I mean, there's just so much fun stuff. So I've taken this formula here, and instead of putting in a value for my x, so instead of putting in an amount that I could pay, I'm actually going to let the calculator put in the amount, and then it's going to tell me how much I can borrow based on what I'm willing to pay back per month. So it's quite a formula. So let's go back here. On my calculator, I'm actually just going to share with you both screens so you can see sort of where I'm going. So we're going to type in a fraction button, and then we're going to put in an X for my payment. Okay, then we're going to have brackets 1 minus open brackets 1 plus 10 over 100, and it is compounded monthly, which is where that times 12 comes from, and then close your brackets. Then we have to the power of 5 years, and where it's monthly, so again multiplied by 12. Okay, then we close those brackets, and then we have 10 over 100 times 12. Okay, so yeah, I know it's quite a complicated formula, which is why I wanted you to see what I was doing so you could sort of follow along. So let me just share only my calculator so it's less distracting. So from there, let's just delete the compound interest formula, and we'll start at 0, and I'll make my step 1. So in other words, if I'm willing to pay back 1 Rand a month over 5 years, I can borrow 47 Rand right now. If I'm willing to pay back 5 Rand a month, I can borrow 235 Rand over 5 years, which is ridiculous. And the reason that I'm doing this is because I want to show you the crazy of this ridiculousness. So what we're going to do is we're going to leave our formula here, and we're going to instead change our steps to steps of 100. So now we are paying back in increments of 100 Rand a month. Okay, so if I'm willing to pay back 500 Rand a month, I can borrow right now 23,500 Rand and pay it back over 5 years. Oh, sorry, Lawrence. I know the network is frustrating. So if I'm willing to pay back 1,000 Rand, I can borrow 47,000 Rand. If I'm willing to pay back 1,500 Rand, I can borrow 70,000 Rand. And you can see this is actually how people calculate their affordability when they want to buy a car. Now, the other nice thing is, if we went right back to the front and instead we said, okay, if my present value is 200,000 Rand minus, and then we used an X there, we can see how long it would take, how much it would take, what payment value, sorry guys, it would take to pay it off monthly. So you'll see if we just drop down here, we're solving for X basically by using our table mode, which is pretty cool. Oh, here we go. So it's somewhere between 4,200 Rand and 4,300 Rand a month. And then of course you can scale it. So if I went back now, if I went back and I said my start was 4,200, and this time I made my steps 10, we can now get an even more accurate value. So it's 4,240, and you can work trial and error like that. So basically, if you pay 4,250 Rand, it will take you 5 years to pay off 200,000 Rand using your present value annuity. So it's a really nice way for showing students how present value is actually working and how it's calculated and where all of those values come from. Awesome. So that's it. The last thing that I want to show you, calculator maths-wise, is solving trig equations. And this is really nice. So, you know, it often becomes quite complicated when we start substituting in the K value. So I'm not going to go through all of these steps here because I'm sure you're following with me, right? So of course, what we do is we get a reference angle on the calculator, and then we get a general solution. Now, the cool thing here is what you can do on your calculator is, I'm going to share both screens so you can see, is you can actually type in your general solution into your function. So I'm going to have negative 10.53 plus, and instead of K, we're obviously going to use X times 360. And then in function 2, I'll do this one here. So 130.53 plus x times 360. And now, obviously, we'll start again at 0 and we'll make our step 1 because we're substituting integers in. And then if we wanted, here we wanted answers between, oopsie, I didn't actually specify. Say between 0 and 180. Then on your calculator, what you would do is look for between 0 and 180. And you can see the only answer is here at 130. So it's a really nice way. And then if you wanted to go wider or smaller, depending obviously on what you're looking for, then you can see all of your answers there, which makes it really, really awesome. Exactly, Celia, which is why I think it's such a nice way to teach trigonometry, solving trig equations. I mean, it's such a nice shortcut, and it takes away all of that crazy, lots of substitution, and just gives you what you need. And I feel like this is often where our students fall down, is this part of the substitution, they get stuck, and then they go cray-cray, and it's not. Anyway, so awesome. So that's the maths portion. I need maybe 5 more minutes of your time, guys. So the next thing I want to share with you is about Sharpies. So Sharpies is a maths reward program that is just for maths teachers, and basically it allows you to earn points, and you can exchange those points for headphones, laptop bags, for calculators. You can donate your points to the Future Fund, which is a fund that sends calculators to students in need. So that's a possibility. And then the links here, you can sign up for Future Fund at this link. And then, of course, if you tell your friends, you also get points for doing that as well. Thanks, Abel. It is. Maths is so absolutely. Then these free resources are some that I've used as a tutor for maths and as a maths teacher. So the link for the simulator, again, if you need it, you can just download it. It is free of charge. Then GeoGebra's link, Maths Sharp has got grade 8 to 12 maths, math literacy, and technical maths worksheets that you can download. They're all free. All you need to do is register as a maths teacher. So it's free. There's exam papers, lots of cool stuff. eClassroom is not free, but it is nice for primary school guys. Then mathdrills.com, awesome. And my favorite one is worksheetworks.com, which is for the younger guys. And then I've created my own one called themathsjourney.com, and you can go and download grade 7 worksheets. I've just started creating stuff as well. Thanks, Stevie. Cool. For those of you who are watching on YouTube, thank you so much for your time. I hope you found the workshop useful and you gained something from it.